Today we're going to work on some right triangle trigonometry, and rather than just getting a triangle with things filled out for us and we just have to label it, we're going to get scenarios or word problems where we actually have to draw out our picture and see what's happening in the scenario, and then we're able to solve using our trig ratios.
Here's our first problem, our first scenario. A ladder 6 meters long just reaches the top of a building, and its foot makes a 76-degree angle with the ground. Which of the following equations could be used to calculate the height, h, of the building? So let's draw a picture for this. I like to see things visually. So first we can have our building. Then we have a ladder, and we know that that ladder is 6 meters. And we know that with the ground, that bottom line there, the ladder is going to make a 76-degree angle. And we're looking for the height of that building. If we look at our SOHCAHTOA, our sine, cosine, and tangent right triangle ratios, we can see, well, first this is going to be a right triangle, right? We can start and figure out which ratio we can use. So I like to always label my hypotenuse first. So we go straight across from that right angle on our triangle, and we have our hypotenuse. Then, because for some reason I kind of struggle, and we all kind of struggle with finding the adjacent one, I like to go straight across from our angle, because remember, all of these are related to the angle. So how are these sides related to our angle in question? And I'm going to say that the height is the opposite side from the angle of 76 degrees. So what is left is going to be our adjacent side. Now we look at this and we want to know the height, and we have the hypotenuse. We don't want to look at the adjacent side. We don't need to know anything about that right now. So I go up to my SOHCAHTOA, and we want something that includes opposite and hypotenuse. And we will see that our sine ratio will use the opposite and the hypotenuse on this. So what we can do is we can say that the sine of our angle, so the sine of 76 degrees, we always put our degrees inside of our parentheses there next to our sine, is going to be equal to opposite, which in this case is h, over the hypotenuse, which will be 6. So we can go back to our answer choice, and we can see that the first one, I, will work for us. Now, since my answer choices also go along with, maybe I can use 1 and 2, or 1, 2, and 3, maybe we should just check these out a little bit. Well, we know that within a triangle, there are 180 degrees. So if we take 180 minus the 90-degree angle that we know, and minus the 76-degree angle that we know, we get that that extra, or that last angle, that third angle, is going to be 14 degrees. So if we use our sine, cosine, and tangent ratios, maybe we can come up with something that has to do with cosine. So if we are looking at this 14-degree angle, I'm going to do the same thing I did before. So this 6 meters is again my hypotenuse. And I like to go across from my angle in question to the other side. And that's going to be opposite, which we don't know anything about right now. And then the last side that is left, we will say that's adjacent. It's the side that is right next to the 14 degrees that we're looking at. But it's not the hypotenuse. So if we look at this, we can see that we don't need anything to do with the opposite side of this one. We have adjacent, and we have hypotenuse. So if we go through our SOHCAHTOA, or our sine, cosine, and tangent ratios, sine uses opposite and hypotenuse. I don't need the opposite side on this one, so we're not going to use sine. If we move on to cosine, we need the adjacent side and the hypotenuse, or want to know something about the adjacent side and the hypotenuse in order to use this ratio. So we will be able to use cosine for this. So if we say cosine, and our angle degree, our angle measure is going to go inside of those parentheses, and cosine is adjacent over hypotenuse. So we have our height, which is our adjacent side, over our hypotenuse, which is 6. So sometimes our answer choices don't always look like we started with, but we know that we can move this 6 to the other side by using its inverse operation. So if h is being divided by 6, we are able to multiply both sides by 6, and these 6's over here are going to divide to 1, which just leaves us with 6 times the cosine of 14 is equal to h, which gives us the answer choice of 2. So 1 and 2 can be used. Now if we look at our third choice, cosine of 76, we already found out in the first way that we did this with sine that if we're using 76-degree angle, we're going to have sine because we already know our opposite and our hypotenuse, or we want to know our opposite and we have our hypotenuse. So cosine of that.
Our next problem is also going to be about ladders. It says the safety instructions for a 20-foot ladder indicate that the ladder should not be included at more than a 70-degree angle with the ground. Suppose the ladder is leaning against a house at a 20-degree angle. Find the following: the distance from the base of the house to the foot of the ladder, and how far up the side of the house the ladder reaches. So we can draw a picture. We have our side of our house with our ladder leaning up against it. The ladder is going to be 20 feet long, and with the ground it's going to make that 20-degree angle. Be sure that we're looking at that 20 degrees. The 70 degrees is just telling us what safety instructions are telling us for this, but we want to know what we've got at 20 degrees. Here we have the height of the building or the house and the base or the distance that the ladder is from the bottom of the house. And we can use our SOHCAHTOA once again. We're looking at our 20-degree angle. So we can go ahead and label this. Is going to make a right angle, the ground with the house. I like to label my hypotenuse first. So the 20 feet is our hypotenuse. Then we like to go across from our angle that is in question, and that will be our opposite side. And then the last one, the adjacent side, the one that's connecting our angle to our 90-degree right angle. Then we can look at our SOHCAHTOA. So if we were, let's start with A, the distance from the house, from the base of the house to the foot of the ladder. So we're looking for B, we're looking for the adjacent side. SOHCAHTOA tells us that we will need the adjacent and we will need the hypotenuse. Same thing over here. So we're looking for the adjacent and we have the hypotenuse. And don't get that confused with the H over here for height. So we can use cosine. So we'll say cosine of our angle, which is 20 degrees, which is going to be equal to the adjacent side B over our hypotenuse, which is 20. Now we're looking for B, so we need to find that variable. Remember, the cosine of 20 is just a decimal. If you want to go ahead and change that into a decimal, that's perfectly fine. But in order to get B by itself, it is being divided by 20, so we need to do some multiplication. So if we multiply this side by 20, we can multiply the other side by 20, the cosine, and those 20s that we multiplied on one side are going to divide to 1. Next, we can find the cosine of 20 times 20, which is going to give us about 18.793. And this will be... So we've not answered the entire question. We found that the base, or the distance from the house to the bottom of the ladder, is about 18.793 feet. But we still need to find how far up the side of the house the ladder is going to reach, which is this h right here. We are able to use our trig ratios if we want to. We can say that this is the opposite side. Across from my right angle is going to be my hypotenuse. And then the side that is going to connect my angle to my right angle will be my adjacent side. We can do that again if we want and use our SOHCAHTOA, but look for the opposite side this time. We can also use the Pythagorean theorem. So if we want to, we can plug in these numbers for a squared, b squared, and c squared. So we can say that h is our a, so we'll plug in h for a squared. And b, we can just keep that as our b squared, so 18.793 to the second power, and that's going to equal c squared, our hypotenuse squared. If we simplify those numbers, or we expand those numbers, we've got a squared plus 353.18 is equal to 400. We need to get that h by itself, so we are going to subtract 353.18 from both sides, and we get about 46.82. Now, that h is still going to be squared in this case, so we need to take the square root of both sides. And that missing side, the height that this ladder is going to go up the building, is about 6